Okay, my research mostly are in two specific areas. One is fluid mechanics and one is computational mathematics. Now, fluid mechanics as such is a very vast area, and a lot of people work in this area, including physicists and engineer. I'm in the math department. So first, let me, for general audience, explain what fluid dynamics is, so that people have better appreciation of what I'm doing in this area. Now, fluid, we all know. For example, we encounter three different fluids on a daily basis, basically. One is air, one is water, and one is blood. We breathe every day, air, or so to say, oxygen. We take shower in water, and of course, we carry blood with us. So these are the typical three fluids which everybody is aware of, but there are other fluids, such as water, of course water I said, such as honey or ketchup. So all these different kind of fluids, they have different properties. So for example, if you spill water and spill honey, they move at different speeds, and so each fluid has different properties. So that property actually goes by the name viscosity. So there are fluids which are called viscoelastic fluids, they are called viscous fluids, and so on and so forth. Now, fluid dynamics about study of the flow of these fluids. So this is in general broadly my area of research. Now, very specific problem that I take are mostly applied problems. Now, in fluid mechanics, there are specific laws of physics which gives rise to equations that govern the dynamics of fluids, and one such equation is called Navier-Stokes equation, and there are a lot of open problems in Navier-Stokes equations, and many mathematicians look at those problems. And there are also many applied problems which applied mathematicians like me, we look at. So one of the problems that I'm looking at right now has to do with flow of complex fluids, like viscoelastic fluids. For example, all of you know what Sally putty is. Sally putty behaves like fluid at some time scale, and some time scale it behaves like solid, elastic. So those kind of fluids are very difficult to study, especially when it's flowing through a porous media. So some of my research right now concentrate on flow through porous media in the context of oil recovery. So when you want to recover oil from the underground, there is one way to recover more efficiently is to use viscoelastic fluids, or what they call polymers. So, and the fluid equations are not well understood in the context of porous media. In fact, the mathematics and numerical aspects of these equations are very poorly understood, or the mathematical theory is not well developed. So this is one of the area I'm working in right now with one of my students. Then there are many other areas of fluid mechanics also I'm working on my own, which nobody's involved in, and those has to do with water waves. Like when water, you have seen the ocean, the water waves, right? So there are many mathematical problems which has to do with equations of fluid mechanics, and in that context, I'm trying to understand those equations, whether they have solutions for all time or not. You see, the equations that model fluid mechanics, all of them are not well understood. Some of these people don't even know if there are regular solutions of those equations for all time in 3D. And in fact, that's one of the big problems, what is called Clay Millennium problem in the context of fluid mechanics, a Navier-Stokes equation, which model the fluid mechanics. So broadly speaking, this is my research area, and some of my research in this area is basically involved these equations. And now, many engineers also work involving fluid mechanics, but what is the distinction between in math and engineering is the kind of questions that we ask are different most often than what they ask in the context of same problem. It is like looking on two sides of the coin, so we complement each other in that sense. So this is really exciting to see that we are trying to understand the whole field of fluid mechanics by looking at from different angles. So another area of my research is computational mathematics. In that area, basically, I try to understand how the equations that govern fluid dynamics, how they will be solved on a computer. So for that, we have to translate those equations into a different form so that those forms can be put on a computer. It could be encoded in a software, and that process needs a lot of mathematics because the equations that actually govern the fluid mechanics and the equations that actually are encoding in the computer, they're different, but it has to be done in a way so that the solutions are same. So this is not a trivial job, and it needs a lot of understanding of difficult mathematics and analysis, and one part of my research is doing that kind of thing. So one of my students is working in this area now, developing very smart algorithms, what we call it, and so that it can be put on the computer very efficiently and people can use it very, very fast way. It will give you solutions to the equations. So this is one area. Also, I'm interested in data science and machine learning, which these days I'm getting into those areas. These are very exciting areas these days. So this is in a nutshell is my research.